So this is a Groxio monthly, and we try to do these every month. We took one off for the summer to kind of let us kind of visit family and take care of some traveling and things like that. We'd like to pick these up every month on a regular basis. They will run the first Wednesday of the month, and the goal is to be in machine learning within Elixir, somewhere within that ecosystem. So I'd like to talk a little bit about what's happening at Groxio from a content perspective. It's really busy. I'm sure that you've seen that the publishing industry around most languages has kind of fallen off pretty hard. And that has not been true of Elixir. Writing and content publishing is my first love, and Groxio is our attempt to do that. There's a lot of content that's being published. There are a lot of courses that we're offering. But it's a pretty good pace right now. So we release something new every 3 months or so. Okay, so what I'd like to do next is to talk a little bit about Elixir's NX. And so I'm just going to look for Elixir NX. And so this is the umbrella project. It's called Numerical Elixir NX. Has a mascot for the first time in Elixir's history, right? This thing is called a numbat. And the genius of this mascot is it's the only animal that's actually a mascot from Australia that doesn't try to kill you in some way, right? But it's a numbat. It's 6 characters, so it's searchable, and it's the mascot. But what I want to point out is that for something that's released, that's only released about 6 months or so ago, it's already growing tremendously fast. So you see NX, that's the project that supports numerical programming itself. And it does that, it does something called automatic gradient, which tells you the rate of change. And it's very useful for numerical applications like curve fitting, and especially machine learning and things like that. There's Explorer, and this is the project that I told you that is starting to pick up steam. So one of the things that Numerical Elixir has been missing is kind of an ecosystem for how you share, search, and transform tabular data. But data frames is what that's typically called in other languages. Well, that's Explorer in Elixir. There's the machine learning framework, and this is very much its own deal, right? There's nothing really like it. So it has all the support in Numerical Elixir, and we'll talk about in a second how Numerical Elixir is primarily about tensors, and a tensor is a wrapper, and the wrapper supports backends, and the backends are supported by compiler extensions and just-in-time compilation. We'll look at some of that later. And then there's, as you're getting started in machine learning, very often you have, it all comes down to kind of shaping and wrangling the data. And so it turns out it's pretty frustrating to be learning data sets and shaping data sets in a language that you don't know very well. So SciData is a project that allows you to kind of wrap these things up, and it wraps up data sets in a format that's really friendly to Elixir with binaries and tensors and things like that. Okay, but what we're going to do today is we're going to look at another project, and that's the LiveBook. And in that LiveBook, and remember, a LiveBook is just an exploration of prose or text, right? Data and code, right? And so we'll use that kind of collaborative publishing technique to kind of explore the concept of NX, which is tensors, right? Okay, so this is a LiveBook. And one of the things that you'll see in the LiveBook is this left-hand margin. Well, we have bells and whistles like this keyboard template that kind of shows you where the shortcuts are. There's a profile for the user. And so that means that you can actually do things like collaborate with other people that are using the same LiveBook. And then there are some kind of quick hitting tools on the sidebar. but most of the work happens in this main body. And in this main body, I just clicked a button to give me a new markdown cell, right? So I could say, I could have your text here, and then I could say 1, 2, 3, and then I could have markdown for links like link Mikey likes it. So I could specify my own link like that, right? But what we're going to do is we're going to mix in markdown text that I've already filled out. That's kind of the scaffolding for this talk. And I'm going to mix that in with some Elixir content, which will be represented under the hood with just GitHub markdown syntax. So if we drill down into one of these LiveBooks and we looked at one of these, if we looked at one of these Elixir cells, I could say 40 plus 2 to get the ultimate answer to the universe, 42 down here, right? And if I were to export this thing, and I want to include the outputs, well, one of the things that I'll see is this GitHub markdown cell with the Elixir that I dropped in, and I can support the output or not, right? So what that means is that we can use this to hold data, and we could go pull it with Elixir, or we could drop data right into the cell and access it in this way, or access the data from a file or something like that. And so we could basically do everything that I need to in a data science project. I can run these experiments and write up the results at the same time. So in other languages like Python and even Java now, but Julia, you'll also see this kind of ecosystem grow up around these so-called notebooks, right? You have the Jupyter notebook in Python, you have the Julia notebook and the Julia language, and there are a few other ones as well, right? Okay, so let's move on to actually using LiveBook to solve a problem. Well, when you're using LiveBook to solve a problem, just like when you're building any kind of Elixir project, you're going to want to install your own dependencies, right? And normally when you do that within a mix project, you would use your mix.exs script and drop in your dependencies that way. Well, within the LiveBook, one of the new features is mix.install. Now, it wasn't built with a LiveBook specific interface, but it was built with a LiveBook in mind, right? So what this allows me to do is to associate a LiveBook with individual dependencies that are related to it, right? And just so that you could see how this works, I can even use oh, that's cool. So did you see what I highlighted the import, right? And then I could see everything related to import. Now I had this NX one set aside so that you could see this NX. Now it's not going to work. There it is. Okay. You could see this NX help to kind of give you a flavor for what NX is, right? So what I did, I effectively did this, drop this mix install in here. And now, right now, there's no NX module in hex. If there were, all I would have to do is mix install :NX. That's it. And then I'd be off to the races, right? Okay. But so one of the things that I like to do when I'm working with the LiveBook is also to drop in the IEX helpers, because I'm used to kind of being able to see the functions that something exports. I'm used to being able to use the info helper to kind of help me understand what the individual data elements are. And so all I need to do since this is part of native Elixir, all I need to do is effectively drop that import in, and I'll be able to access the IEX helpers from anywhere here, right? Like, for example, I could say, give me some help on NX. And then to evaluate this, I'm just going to press Command Enter. And you can see that this is going to show me, hey, this is the library. That's a collection of functions and types for working with numerical Elixir. And it's really mostly about multi-dimensional data, and that means tensors, right? So then it shows me an example of creating a tensor. So let's go ahead and do this. Let's grab this piece of data and let's drop in an Elixir cell. And let's say tensor is equal to, and I'm going to just recreate what was there, nx.tensor, right? And then I could say, I want a list of lists, 1, 2, and 3, 4, right? Okay. And so this is pretty cool. Already, if all I'm looking at is the tensor, is the results of this operator, I can see that this is not your grandmother's Elixir, right? One of the things that you should see here is that this thing has a shape just like this list of lists does in Elixir, but it also has a type, right? And what this allows me to do is represent the typed data with a much more compact data structure, because in Elixir, data is represented as linked lists. And you can imagine how inefficient list of lists would be if you tried to, for example, access the last list and the last element of that list, right? Then I'd have to find the last list and I'd have to find the last element of that list. So the three things that Elixir's tensors lacked for machine learning, first is an efficient representation for multi-dimensional data. The second is a typed representation for multi-dimensional data. The third thing is random access. Now you can imagine being able to reach right smack into the middle of a tensor is a pretty important thing when you're building out algorithms that are kind of manipulating data in a lot of different ways, right? So the two approaches that the team could have taken, one of them would be to kind of either shelf the data structures in Elixir, and then you would lose all of the goodness that's related to the same reason that all functional languages use linked list as their data structures, and all those algorithms that kind of make those things efficient. They obviously didn't want to do that. So the other thing that they could have done is build a new set of data structures, and then you have to think about, well, how do you handle all of the protocols, and how do I decide to make it eager or lazy? But they said, no, I don't like either one of those options. I'm going to pick option number 3, right? I'm going to pick implementations that are already there, and I'm going to build a skinny wrapper around those, right? But if we look at this tensor, so let's open this up, and I'm just going to use that IEX helper and say info for tensor. I'm going to let that fly. And then it gives me the term, right, which is just the tensor itself. And you can see that this is just an inspected version of the data that I got before. And that makes sense, right? The LiveBook runs it, or IEX it runs it. It gets the term the same way by just inspecting that thing, right? You can see that the data type is a tensor itself. So let's riff on this concept for a second, right? So, so we saw that we could take the, let's actually build an nx.tensor. Okay, so it's telling me that I can't do that, right? So, but I do have a tensor that already exists, this one. So I ought to be able to take that. And we know that there's a struct in there. We ought to see nx.tensor, right? And we do. And remember, in Elixir, a struct is just a map with the underscore struct underscore key, right? So I know that there are additional keys in here. So let's find out what they are. So the keys are struct, which we already knew about. There's the data, which if you think about it, we already knew about that too, right? There are the names of the dimensions, and we didn't give our dimensions, our tensor any dimensions, but we could, right? So for example, we could say, I want you to name these dimensions. The dimension names are y and x, right? So now, if you were paying really careful attention, you saw that the shape of this thing changed with the y here and the x here, right? And if we evaluate this cell as well, we got the same thing for the term, right? All that means is that we still have a tensor, but this is one with dimensional names. And now the third thing was the shape, right? And so that shape is this 2x2 thing here, right? And in fact, we can get the shape of the tensor by saying nx.shape. And this is going to give me a 2x2 tuple. And the way to read this, the outermost shape is first and the innermost shape is second, right? So for example, if I were to change this tensor to be 1, 2, 3, and then 4, 5, 6, what's the shape going to be?
Three and 2.
3, 2. What's the innermost? So the outermost goes first, right?
Mm-hmm.
So that's this one. And this has this bracket as, 2, 3. Yeah.
2, 3.
So I can reevaluate this. And then I see y is 2 and x is 3. And I can reevaluate the shape on down. And I get a shape. I'm still not very good at wrangling the, so you could see the 2 for the outer shape, the y equals 2 and z equals 3, right? Okay, so that's the NX overview. I'm going to go ahead and delete that because we've already talked about did we talk about all those keys? So let's see, the map.keys. Let's put map.keys back. Oh yeah, and so there's a type also. So what was the type of this tensor?
S64.
S64, right? So for example, if I wanted to specify the type here, I can override that. And so this is going to be a tuple. So this is going to be type, name, type, size, right? And so if I want to make this super efficient and all the numbers are small, I could say, give me an unsigned, so an unsigned 8. So the size for integers can be 8, 16, 32, and 64, right? And the types for integers can be either signed or unsigned, right? So I can let that fly. So this could also be signed. This could also be a float. And the sizes for floats, these can be 16 or 32. Or this could also be a brain float. what turns out that in machine learning, the representation under the hood of typical floats isn't ideally constructed for the best possible precision. So the exponent and the what do you call it? Is it the mantissa? The rest of the number are out of balance, right? So I could run this. So now this is a Google brain float, but let's make this an unsigned 16. Cool. So those are the elements of the tensor. So what do we know so far? We know that NX is Elixir's framework for numerical computation. NX is primarily about tensors, and tensors are structures that are wrapped in other environments that have what major elements? What does a tensor struct have in it?
Shape and data and name
and names, so the dimension names and a type, right? And that's it. That's right. So, and everything that's in NX proper is somehow related to working with tensors performant and smooth, right? That's it. That's it. Because if we had to do all of this with these flexible integer sizes and linked lists, you could build these great algorithms in Elixir, but they just absolutely would not perform, right? So the second thing that's going on with NX is that there's a whole new class of processors that's coming out called TPUs that are kind of specialized for machine learning and working with tensors and tensor math. But there's an existing processor type that does this very well, right? And that's the graphical processing units, the GPUs that are already in our systems. And so what you typically do as a data scientist is you use your graphical processing unit on your computer, even in multiple cores, to kind of speed up the execution of models that might take, hours or even days to run. Right. So those are the things that the NX package proper gives you, right? And if you were to drill into NX, what you would see is backends for PyTorch or LiveTorch in Python, and accelerated linear algebra or XLA in Google. And you'll see some other ones as things happen, right? Okay, so let's talk a little bit about tensors. So we've already done a little bit about tensors, but let's create them. Try this one more time. Okay, let's create them several different ways, right? Okay, so one of the things that you'll notice is that an Elixir developer don't do this, right? But an Elixir developer will typically do something like this. Like I might have a range from 1 to 16, right? And then I could say enum.chunk or enum.toList, right? And then I could do an enum.chunk every let's say 8, just to keep the and then I could say reshape, but I want this to be a or how about just index.tensor, and maybe I want these to be I could have a type of unsigned 8s, right? So this gives me a tensor, and this is okay when we're dealing with 16 different elements, right? But machine learning data sets and data science data sets in general are going to be much, much larger. It's a data intensive operation. So what I need to do typically is to use different kinds of, I need to use the primitives within the NX library to create things instead, right? Like for example, this is an Elixir range. In NX, I have something called iota. Let's kill this. And by the way, I'm going to publish this notebook, so you'll be able to have access to it. I'll publish it right away. Oh, right here. So I am. Okay, yeah. So we want this guy, this guy. So I'm going to say nx.io iota, right? And so I want to give this either a shape to match or a tensor with a shape to match. And let's say that we want to take a tensor that is 2 by 2 by 2, right? So all this is going to do is count, right? 0, 1, 2, 3, 4, 5, 6, 7. So that's all the dimensions. 2 times 2 times 2 is 8, right? But I could also say, I want to label this I want to run this across the axis, the 0 axis, right? So my, so that's this axis. Is this the innermost or outermost?
Outermost is first, right?
Outermost first, right? So what if I did something like this or something like this? What would that first row say? 0, 1, 2. So this would count along the innermost, right? So I ought to see 0, 1, 0, 1, 0, 1, 0, 1, right? And I do, right? Well, one of the cool things about creating tensors in NX is that if I had a tensor with names, I could name these, right? And I could basically say, give me an iota along the specific named axis as well, right? Okay, so so I can also create tensors with a feature that we're going to talk a little bit more about called a broadcast. So I could say nx.broadcast, and here again I'm going to take a shape. So I'm going to say 1 by 2 by 3, right? So that's a list of one list that has a list of 2 lists, that has a list of 3 lists. That's kind of the way to read that, right? But I'm going to broadcast the value of 0 to that shape, right? And then I get this individual shape. I could also say nx.random normal, right? And this will give me a random normal distribution. And so maybe I want this along a 2 by 2. Right? So you can see that it's very easy to get a tensor that's initialized with a valid set of numerals, right? So there's a great blog by the creator of NX. His name is Sean Moriarty. So, and there's a tip. There's an MX tip of the week that you should follow. It's really pretty good. And so one of these is how to efficiently create tensors, right? So the next thing that I want to talk about is the idea. Well, first, let me stop for a second and take a question or two.
I have one.
Come on.
Can you do me a favor? Can you change that broadcast number? I just want to make
Yeah.
sure I understand it. Can you change the 0 to something else? Just
Sure. What do you want?
7.
Okay. I'm going to see your 7 and I'm going to
Okay,
raise
yeah,
it
I
to
did
42.
understand it. Okay, so it fills in the entire.
Yeah.
Okay, got it.
So let me show you, let's skip ahead, and we're going to come right back to this. This is killing me here. Okay, you'll see why. So there's a bug in LiveBook, and I have some beautiful formulas, which is the whole reason I created this in advance in the first place, so that you could see the mathematical version. There it is. Okay. So Vanessa, do you see what's going on here? I have this tensor minus this tensor, and it gave me this tensor, right? 5 minus 1 is 4. 6 minus 2 is 4, and so on and so forth, right? So really what I need is a tensor called tensor 2, right? So I'm going to create that tensor. 2 is equal to, and that's going to be, so Vanessa, tell me what this tensor should be. I want to build this one, this 5, 6, 7, 8.
Right. So the shape is 2, 2. And
But I just want a list of lists, right?
yeah,
So the outer list has how many lists in it?
1.
Okay. And what's in that one? So I want 5. So I want a list of 2 lists. This 5, that's a top, and that's the bottom.
Yeah. So you've got, I mean, a list with 5 and 6 and a list with 7 and 8.
That's it. So this is remarkably simple stuff, but you'll see how quickly the concepts stack, right?
Yeah.
Right. And so now we have this tensor, but what we're going to do is we're going to take this and we're going to use first NX itself, an NX function. And do you know what the minus function is in Elixir? Anybody else know?
Oh, you mean like the min, like
The
early?
module, the minus function, that relates to the minus operator. Who can tell me? Patrick is trying to speak up. Come on, Patrick.
That'd be the kernel, wouldn't it?
Yeah, it is. It is, right? So if I say, for example, 2, and then I can pipe that to kernel dot minus 1, that gives me 1, right? Right? So we call this tensor 2, right? But I'm going to say NX dot, this is a numerical definition, but it has its own kernel, right? And I'm going to subtract, tensor. Oh, I changed my tensor. I bit myself. Okay, we got to save that tensor. So how do I fix that, somebody? So this is 1, 2, right? And then I want a 3, 4. You can see I'm not really comfortable with this content yet, right?
Bruce, one question. What happens if both tensors have different types?
If the so I think so there's a couple of hidden questions in there, right? So one of them is tensor type, right? And I think that we would see type coercion in that for primitive types, right? There's another implicit question. What happens when the tensors have a different shape, right? And we're going to talk about that explicitly next. So, so I think that there is type coercion. Yeah, in fact, I'm sure of it, because Elixir is going to use, is going to push these operations into the compilers for other languages. So type coercion is going to be what happens. Okay.
Thanks.
No problem. So, okay, so now I have this, I have the name, I'm not here yet. Tensor. Sorry, I know I'm making you dizzy. I'm going to try to slow down and say, okay. So what we have is Tensor 2, which has which shape?
2, 2.
And Tensor has which shape?
Now it has 2, 2.
Yes. So, and you can see that this is the same as this right here. This is 4, 4, 4, 4, right? But it's ugly. So what do? Well, it turns out that I can actually, well, tell you what, let's come back to, no, I want to solve this now. That's too ugly for me. I can't bear to look at it, right? So what I want to do is I want to say works, but ugly. Use right. So instead, I want to use these tensor aware operations, right? And so I'm going to create an Elixir cell. And the first thing I'm going to do is import nx.defn. So a defn is a numerical definition. It's a subset of Elixir that supports backends and backend compilers and tensors, right? And so what I can do is now I can say def module, right? And maybe we'll call this a math subset, right? And then maybe I don't like the minus function. Maybe I want to kind of, I want to take advantage of the minus operator and I want to be able to subtract. Right? Okay. So if we have imported defn, that gives me a numerical definition. And if NX has imported the kernel for defn, what do we know about this? So that's going to work with scalars. What else does it work with?
Tensors.
Tensors, which is the whole point of this, right? So I can run this, and now I could say, this is a lot prettier, Vanessa. So now I could say, in math subset dot subtract and that's cool. That to me is really, really satisfying, right? And the cool thing about it is that we've used the abstractions underneath Elixir without cheating, right? And we've let the abstractions underneath do the heavy lifting, right? So what's happening is when this is executed, it's building an intermediate form, which is then passed off to a just-in-time compiler. We don't see any of that, right? We just see the beautiful expressions that that are tensor aware, right? So let's talk a little bit more about what a tensor aware expression is, and then we'll kind of wrap it up here and pick up the conversation the next time, right? Okay, so let's look at tensor -1, right? Intuitively, so what's in tensor? Anybody remember?
I think so. We had data, names, shape,
But
and
what is the data in this tensor?
oh, in that one, in tensor as it was, that was a 2x2 with 1, 2, 3, 4.
1, 2, 3, 4, right? And so if I subtract the scalar 1, what should happen?
0, 1, 2, 3.
0, 1, 2, 3, right? So we could try that, right? So so this is what I'm going to try to do, right? Sorry about this. Okay. So this is what I'm looking at, right? what's going to happen is that we need some type of mechanism that does the equivalent of type coercion, right? And that mechanism is called broadcast, right? So that's why you saw the idea, if I want to broadcast this thing right here, this -1 right here, I want to broadcast that into the shape of the tensor on the left, right? So that I come up with this. And so that's why I wrote this line of code. So nx.broadcast, and I want to broadcast the tensor, which is, or I'm sorry, the scalar, which is 1, but I want to broadcast that into a 2x2 shape. And there it is. Right. So now I can do something like this. I could say the math subset dot subtract, and I can either do, and that works just fine. Vanessa, that's exactly what you expected it to be, right?
That was my light bulb. Yeah, thank you.
Or I could say, so let's say 5 tensor. Five minus 1, 2, 3, 4 gives me 4, 3, 2, 1, which is cool, right? So now what we have is we have broadcasts of scalars, and we have tensor math with like shapes. Well, what about shapes that aren't the same? Like what happens if we want to add a row or subtract a row from everything into a tensor? Something like 1, 2, 3, 4 minus 1, 2. How can we test whether this is going to work? What did we do to that scalar 1 to make it fit?
You mean when you manually went back and took out the third the third number, the third argument?
Oh, no, I'm saying, what did we do in this problem right here to make that 1?
We coerced it, yeah.
And do you remember the function name?
Broadcast?
Broadcast.
Yes. So I ought to be able to say, so nx.broadcast, right? And this only works on tensor, so I have to translate this into a tensor, right? So it's nx.tensor. This is ugly, right? So I'm going to take this 1, 2, and I'm going to pipe that to nx.tensor. And then I'm going to pipe that thing to nx.broadcast. And what shape do I need? What shape is this in? That's 2, 2, right? Now that is satisfying, right? Right? So then I ought to be able to do, in Elixir, I ought to just be able to do this subtraction right here without doing any work, because there's an implicit broadcast in there. So I say nx.tensor, or nx dot, I'm sorry, my math, so math, so what did I call the module? Math subset. Math subset dot subtract, and then I want to subtract, I want to start with tensor, and then I want to subtract an nx, a tensor that has, that is just the 1, 2, like this, right? And I get the 0, 0, 2, 2, right? Or check this. What if I took this thing and I wanted a column instead, right? So a column would be something like this. That's a column, right? And there it is. Right, so what I'm saying is that there is a set of rules that's explicit for being able to handle broadcasts, right? And some of it is that we can discard dimensions that are 0. We can repeat when I have dimensions that are only a size of 1. And I could basically do copies until the things match and have a whole family of math called linear algebra that works. And so when we get together next week, what we'll do is we'll talk about the linear algebra rules around a dot product, right? We'll talk about what that means and what that means for machine learning. And so we didn't get to plots. That's pretty good. We still did really well. So what I'll try to do is commit this to GitHub this afternoon and send this and kind of, tack a few notes around so that you'll be able to navigate it and understand what happened. But then what we're going to start to do is build the intuition. So the next 2 Groxio Monthlies, first we're going to talk about how do we do multiplication, right? That's its own animal. It's called a dot product, and it's really one of the central concepts in this family of math. And then the second thing that we're going to do is we're going to build a linear regression. And that's going to take us into the beginning of the space that axon occupies. And once you have it's kind of like building a counter in OTP, right? So we're building a dead simple piece of axon so that you could piece together the intuition for how the individual pieces work, right? Okay, so to wrap up, if you want to know more, a few of your peers have already said it. Groxio subscription is a great way to go. It's only $150, and it gives you access to OTP and live view and a lot of these things in a self-study kind of format. So if you're really struggling with the Elixir part, or you get the basics of Elixir, but you're not getting the abstractions that are underneath, come get a subscription or take a course if you want to. So if you want to read from some of the experts that created the frameworks, Dashbit has a couple of great announcement blogs and videos. Go to dashbit.com. There's also Sean Moriarty's blog of tips. And Sean also has a blog that was published on Dockyard's blog feed. And that is called NX Up and Running. And I'll post links to all those here. And then I would also point out that if you want to see how things like slicing and broadcasting and operations and defins work under the hood, and you want another layer of depth, go to the documentation for these individual functions and get it that way. It's really excellent. So it turns out that within the NX project right now, the individual functions have excellent documentation. What it's missing right now is kind of the overview that I just gave you. So that's it.